This is Trigonometry 3D, and we have a box. Above the box there is some sort of a prism. So this is a 3D picture. So this is what it looks like. So when you have something like this, so we can take a look here. So this is from the front view and this is from the side view, and if you see below, although from this direction it doesn't look like a rectangle, but the floor is a rectangle. You can actually look it from behind. So this is what the floor looks like. So this is a rectangle with every angle 90 degree. So whatever it looks like on 2D, in 3D, this is a box, and above the box there is a prism. So we can just look for all the right angle triangles hidden in the corners. So let's start. The first thing that we have to do is we have to find the height of the building. Now the height of the building is from here to here. So this is the height of the building. So if we find from here to here this height, we already know that the height of the square is 2.5 meter. So we can easily find this by drawing a triangle. So we know this is an isosceles triangle. So C, B, D. So this is 3, this is 3, and since this is 4, this would also be 4. So we need the height. So let me call this X. So that makes it 2 and that makes it 2. So you mention the triangle. In triangle CXB, using the Pythagorean theorem, you know, opposite the 90 degree is the hypotenuse. So this is 3 squared equals to sum of the square of the other two. So this is 2 squared plus this is CX. So this is CX squared. So 3 squared is 9 minus 2 squared is 4 equals to CX squared. Therefore CX squared equals to 5. Therefore CX equals to square root of 5. Now one more thing is important. Since this is squared, we have to write plus minus. But since this is geometry and length of a side cannot be negative, it is alright if we don't give the plus minus sign. So the answer would be height of the building is this CX plus this height over here, which is 2.5 meter. So this would be square root of 5 plus 2.5 meter. Now the answer has to be in 3 significant figure. So let's bring out the calculator. So that makes it square root of 5 plus 2.5. That makes it 4.74 to be 3 significant figure. But remember, your answer would be round of error for the next question if you keep using this. So you have to write something longer than that. So 4.7361 should do it. 4.7361. So the answer is height 4.74 meter. But when you need to use this information that does not have just the 3 significant figure but the longer version of the question. Now question number B. Question number B, we have to find the angle between HE. So this is H. So if I draw a picture here, so this is H and this is E. So this is HE with the horizontal. Now the horizontal is this rectangle over here. So it might be clear what the angle is, but you draw here a line through the midpoint of this shape. And with the floor, here it's the 90 degree and this is the angle that you have to look for. Let me show you in 3D. So here we are. So in 3D, what we are looking for is we have H here. So if I put a point here, H, and this is E all the way here in this corner. So this is HE. Now from here, we have to put a vertical point here exactly in the middle. Just in the middle, the vertical point. So this is the midpoint. So this is the vertical from H. When we drop that point, it's here. And on the floor, we join this. And this is a 90 degree. Why is this a 90 degree? If you just rotate the view over here, you can notice that this triangle, this is vertical and this is on the floor. So this has to be 90 degree. And the angle between this HE with the ground is basically this angle. And all you have to do for noticing it is rotate it around and you'll see that this is the right angle triangle we're looking for. So the triangle we're looking for here is HE, and this is the midpoint of this base. So if we get back to here, we can now draw a miniature triangle. So the miniature triangle would be H, this point is E, this point is E, and here this point, let me call it Y. So we know from the previous question that the height of the building is 4.7361. So we can consider this to be 4.7361, the height of the building. So in order to find this angle which we are looking for, we're looking for the angle between HE and the horizontal, which means the rectangle on the floor. So we have to find this angle. So in order to find this angle, we need this side and one more side. So EY. So can we find EY? Now if you take a look here, if this is E and this is Y, so it's on the floor. Let's take a look here. This is on the floor, and this is what it looks like. If you take a look at the floor is nothing but a rectangle, and this is the line we are talking about. We already know that this side is 5 meter. This side is 5 meter. So this is 5 meter, and this is 90 degree because on the rectangle we have 90 degrees at the corners. Now here, this side FJ is equals to 4. So since this is through the midpoint, this is going to be 2. Half of 4 is going to be 2. So this is going to be 2, and this is going to be 2, and this is 5. So remember that. So when we have to draw another right angle triangle here. So the right angle triangle is going to be something like this. Here, the 90 degree is on the corner of the rectangle. So this is E, this is J. So this is the 90 degree, and this is the Y here on the floor. Remember, this one is on the floor. So EJ, this is 5, and since this is 4, half of this is going to be 2. So now we can start with this. In triangle EJY, remember the triangle on the floor, we can find EY. EY is the hypotenuse, so using the Pythagorean theorem, so EY squared equals to 5 squared plus 2 squared. That makes it 25 plus 4, which is 29. So therefore EY equals to square root of 29. So now that we know 29, square root of 29, that this portion here is square root of 29. So now we can rotate the view and get back to the original view. So this EY is square root of 29. We know the height, 7 point, what we found in the previous one. So we know this, we know this. We can find this angle very easily. So this is EY square root of 29. So now we can write. So in triangle HYE, now this triangle we are using, so we can write tan theta equals to 4.7361 divided by square root of 29. Remember, EY is square root of 29. So therefore theta equals to tan inverse of 4.7361 square root of 29. That makes it tan inverse 4.7361 divided by square root of 29. So this is going to be 41.331 degree, and the answer should be the angle between HE and the horizontal is, remember we need 1 decimal places here, so it is going to be 41.3 degree. That's it. The next question, question number C, is the angle between CHID and the horizontal. Let's take a look. So CHID is this plane over here, and the horizontal is this one. Anything horizontal is a rectangle which is like this. So if we want to find the angle between this plane and that plane, the angle is more or less the same throughout. If you take a look here, let me show you in 3D. If you want to find the angle between this plane and the angle between this one here on the floor, this plane and the one on the floor here, then this and that is going to be this angle over here. Can you see it here? From the front view, this is going to be the angle. So the angle is going to be angle CDB. So we already have this angle, this isosceles triangle that we have drawn up. So all we have to find the angle is CDB. So all we have to write is question number C. In triangle CXD or CXB, doesn't matter because this angle is this angle, the base angles are same. So in triangle CXD, so I'm going to use this triangle. So I know the base is 2 centimeter and the hypotenuse opposite the 90 degrees 3. So I can write cos theta, this angle I'm using, adjacent 2 divided by hypotenuse 3. So therefore theta equals to cos inverse of 2 by 3. So let's calculate cos inverse. So cos inverse of 2 by 3 is going to be, so cos inverse of 2 by 3, that is 48.1897. 48.1897. So the answer is going to be angle between CHID and the horizontal is, we need one decimal place, that means from the beginning 48.2 degree. That's the answer. Question number D, the acute angle between GE and BJ. So GE is this one from one corner to this corner, and BJ is this one. So it's like this. This is from one corner to the other corner. This is the line, and the other one is from this point all the way from to here. Now if you notice here that these two lines are equal. GE from this point to this point, it's, if you consider this box only, from this point to this point, and BJ from this point to this point, they're exactly equal. If you take a look from this lateral view, they're like the diagonal of a rectangle. They're exactly equal, and they also have to be equal for another reason. Another reason is that if this is a box, from one corner of the box to the other corner, the length is the same. So this length and this length, they have to be equal. So they're like contained in a rectangle where this is the length of the rectangle and this is the height of the rectangle. So if you take a look here, so this is G, so this is GE, this is B, this is BJ. These two lines, they have to be equal, and the angle between them is actually the angle here. You can draw it separately. So this one BJ and this one GE. So these two lines are equal, and since it's inside the box and they're intersecting at the center of the box, they also bisect each other. That's how the geometry of boxes work. So this is where they meet. Let me call it, since we have already used X and Y, let me call it Z. So since BJ and GE are equal and they bisect each other, so this makes it an isosceles triangle, and the angle between them that we're looking for, it's either this angle or that angle, doesn't matter. Whatever angle we find, if it's not acute angle, meaning not less than 90 degree, we can subtract it from 180 degree. So this is the angle we're looking for, and this is BJ, BG. Now if you take a look here from the diagram, we already know BG is 5 meter. So we already know that. So BG is 5 meter. So this is going to be 5 meter. Now what we need now, if we know the length of BE, then this is half of BE. so we will know the height. Or if we can find the length of GE, this is half of GE. So either way, we can either find BE and take half of BE to be the height of this isosceles triangle, or we can calculate GE and consider this, since they're bisecting each other, we can consider the length of GZ and use this isosceles triangle to find this angle theta. So whatever is easier. So let's take a look which is simpler to do. Now in this picture, if we have to find GE, then we have to use a right angle triangle. We have to find FE, and we already know what GF is. So we have to, in order to find GE, we already know the height of this. This is 2.5, and we need this on the floor. What's on the rectangle? So that's what we need. On the other hand, if we can find BE, BE can directly be found by this right angle triangle, because we know this is a rectangle also. So instead, if we take this face and find BE, that would be simpler to do. So let's find BE. So I'm using this right angle triangle. So this is B, this is E, and this point over here is A. So this is A, so BAE. So we know this is 4 and we know this is 2.5. This is part of a rectangle, so this is 90 degrees. So you start off with, in triangle BAE, by Pythagorean theorem, BE squared equals to 2.5 squared plus 4 squared. So that makes it, so you know, this is 2.5 and this is 4. So we can find this BE. So let's use the calculator. So 2.5 squared plus 4 squared, that makes it 22.25. 22.25. Therefore, BE equals to square root of 22.25, which is square root of 22.25 is going to be 4.71699. 4.71699. Now here, the height of this isosceles triangle, since Z is in the center, it is going to be half of BE. Remember that. Here, this thing is exactly at the heart of the box, at the center of the box. That means if this is the length, half of this is going to be from here to here. So half of that. So this length is going to be half of this. So let me redraw this isosceles triangle. So this isosceles triangle is going to be, this is B, this is G, this is Z. So let me, this is 5 meter. So let me draw another height here. We need to find this angle. So this, let me call this W. So if BE is 4.71699, then ZW is going to be half of that. So therefore, ZW is half of that since it's in the center. So half of 4.71699, and that is going to be, so divided by 2, 2.3585. So 2.3585. So that is the height. So for finding the entire angle, this is 2.5 and the height is 2.3585. So in order to find this angle, we can either use the cosine rule, but here it's easier because we don't know this side and that side. We can just use the ratio. So in triangle ZWG, we can find this angle. Let me call this again. Let me call this theta. We are naming it theta over and over again, but as long as we restate it properly, it's fine. So here we can write tan theta is opposite, which is 2.5, divided by adjacent WZ, which is 2.3585. Therefore, the theta is going to be tan inverse of 2.5 divided by 2.3585, and that makes it So tan inverse of 2.5 divided by, this is also stored in the answer, so divided by answer, equals to 46.67. 46.67. Since we are at the end of the sum, we don't have to worry about round off error. So the angle we are looking for, so angle between GE and BJ equals to 2 into 46.67, because we found half of it. We need the entire angle between BE and BJ and GE. So that is going to be this angle into 2. So 93.34. 93.34. 93.34 degree. But remember, the question was, we have to find the acute angle. Find the acute angle. Acute angle means less than 90 degree. So I guess we should have found this angle instead of this. It's fine, since this is a straight angle, all I have to do is subtract it 180 degrees. So that's it. We find that acute angle. So write the answer acute angle equals to 180 degree minus 93.34, and that is going to give us, so 180 minus 93.34, and it is going to be 86.7 degree to 1 decimal place.